Hello viewers, welcome back to my channel. A lot of studies are single phase and parallel for which the baseline is defined as the last non-missing value on or before the first dosing date. In this case, there is only one baseline per subject per parameter. This is the simplest case and the implementation is straightforward. But in other cases, for example, in a crossover study, the baseline for a period could be defined as the last non-missing value on or before the first dosing date of each period. In these cases, there is one baseline per subject per parameter per period. In some other studies, baseline may be defined as time matched. In these cases, there can be one baseline per subject per parameter per visit. And in some studies, for instance, in the extension phase, the baseline can be dependent on the arm. According to the ADaM IG 1.0 or 1.1, new records needs to be created when there is more than one baseline. But the question arises is, do we always need to create new records for all subjects and all parameters? When base type is needed, how to implement the D type accordingly? In this video, we will be discussing about how to implement the ADaM compliant BDS dataset for various cases of baseline definition one may face. So let's get started. Now let's first understand what is base type. Base type identifies the definition of baseline corresponding to base on the current row. If there are more than one definition of baseline in a parameter, base type must be populated on all rows for that parameter according to all rows based on the given parameter. In this video, we will discuss then when is base type needed for the single phase parallel study, for two-phase parallel study, time-matched baseline studies, and by-visit baseline studies. Let's start with the first case, that is the single phase parallel study. If the study is a parallel single phase study, the baseline is usually defined as the last non-missing value on or before the first dosing date. Right now, I'm showing you the SDTM data for such scenario. In this case, the implementation of baseline is in ADaM pretty straightforward. One can use the ABLFL to flag the baseline records and populate the baseline values to each record using the variable base. So the ADaM dataset right now, which I'm showing you as a part of table 2, is pretty much straightforward. Here, please note that since there is only one definition of baseline, base type is not needed to be populated. While this approach to implementing single baseline flag, ABLFL, is one of the most widely used approach, is to define the base, then merge into the dataset and finally flag the baseline records. But this approach may result in multiple records flagged as baseline in some cases, such as there are multiple records at the same time. To avoid this error, a modified approach can be used. The approach is to define a intermediate variable first, for instance, baseline variable, and then define all non-missing values on or before the first dosing date, then sort the data by the uSubject ID, param CD, and the intermediate variable created for the baseline variable, say base candidate, and then the fourth variable in the sorting variable will be the ADT. Then we will use this variable, that is which we have created, that is the base candidate, and then flag the last base candidate as the ABLFL equals to Y. In this approach, there will never be multiple records flagged as baseline. To know the SAS code of how this approach can be implemented, please go through my video on how to create the ABLFL base change and the percentage variables which I have created, where I'm showing you the complete SAS code on how to achieve this purpose. So make sure, if you want to know how the implementation of the baseline flag in single parallel study, you do watch my video on that SAS code. Now let's see the second case, that is the two-phase parallel studies. If a study is a two-phase study in which a subject can have two different treatments in different phases, assuming that there is no washout period between the two treatment phases. In this type of studies, baseline is defined as the last non-missing value on or before the first dosing date of each treatment phase. As a result, there will be two different baselines per subject per parameter. Right now, I'm showing you the SDTM dataset of such scenario. In this case, the implementation of baseline is not straightforward. In this example, as shown in this table, for subject 10101, the interocular pressure value at visit 2, that is the 20 mmHg result, is the baseline for all records. In the meantime, the interocular pressure value at visit 5, which is the value of 25 mmHg, is the baseline for all records, the second treatment phase. The treatment B highlighted in yellow in this table. So for records for at visit 6, 7 and 8, there are two baseline values, one for visit 2 and one from the visit 5. To implement, now the question arises is how to implement this. Intuitively, one may think about adding variables A, B, L, F, L to base to change to percentage to etc. variables. But this is not ADaM compliant. According to ADaM IG version 1.0 and 1.1, rule number 6 says that when there is more than one definition of baseline, each additional definition of baseline requires the creation of its own set of rows. New rows, not new columns, needs to be created to implement the second baseline. So right now I'm showing you a table 4 in this here, which is the ADaM dataset resulting from the above shown SDTM dataset. This table is one of the possible implementations. In this table, rows highlighted in green are the newly created records. In this example, there are two sets of records which can be distinguished by base type. The first set of records has base type equals to screening, and the second set of records has base type equals to period 01. The first set of records uses the baseline from screening period, while the second set of records uses the baseline from the period 1, that is from the visit 5. In this case, please note that the base type is required because there are multiple definitions of baselines. In this approach, no matter whether a subject received two different treatments in the two different phases or received the same treatment in two different treatment phases, there are two sets of record. In the first set of records, the baseline is picked from the last non-missing value on or before the first dosing date. And in the second set of records, the baseline is picked from the last non-missing values on or before the first dosing date of the second period. In case 2, that is the two-phase parallel studies, what we have discussed so far is the case when a subject took same drug in the two phases. But how we will map the base type or the baseline records for a subject which took different drugs in the two phases. In some studies, the baseline for records in the second treatment phase can be dependent on whether a subject took different treatment in the two treatment phases. If a subject took the same drug in both phases, the baseline for both phases are the same. However, if a subject took different drugs in the two phases, the baseline for the first phase is from the screening visit and the baseline for the second phase is from the last non-missing values before the start of the extension phase. For this analysis, the implementation which we have just discussed is not perfect while creating the table programming. In table programs, one have to select the right set of records for subject who changed treatment or who did not change treatments. To make the table programming easier, one can modify the above discussed approach by selecting the subject who did not change the treatment, such as the subject 10101 in this table, and just create the first set of records. Please note that for this subject 10101 who did not change the treatment in the two phases, you can see there is only one set of records where the base type is populated as screening and the A phase variable is giving the information of the phase the subject is in. For subjects who changed treatment, such as the subject 10102 in this example, use the first baseline for acute phase analysis and use the second baseline for the extension phase analysis. So what will be the result of the ADaM dataset? You can see that here in this example, the second subject who did change the treatment in the second phase, you can see the TRTP variable showing the difference that the subject has moved from drug A to drug B, from going to the screening to extension phase, acute to extension phase. So how we are going to populate here, that you note that for the first phase, we are keeping all the original set of records, which is for the visit 2, 3, 4, and 5. We have the screening base type, and those are the screening records. But to show the extension records, what we have done is we have created a new record where we are having the baseline defined as the last record, last non-missing record before the start of the treatment in the second phase. So in this scenario, the record highlighted in green is showing the information of the baseline records for the acute phase or the extent from the acute phase to the extension phase. So in this example, what is happening is for subject 10101 who took the same drug in acute and extension phase, there is only one set of records with the base type values equals to screening for all the records. Whereas for second subject, that is the subject 10102 who took different drugs in acute and extension phase, there are two set of records and that can be distinguished by the base type value. Only one new record has been created per subject per parameter in this case. It is also worth noting that the newly created record highlighted in green, drug B is populated as TRT, which can facilitate the table programming. Please note that the original record was having the value of drug A when it was a part of the screening base type records. But when this record becomes your baseline records for the extension phase, we have we have to show the correct treatment for which this record will act as the baseline record. One may wonder whether creating only one new record violates the rule 6 of the ADaM IG version 1.0 or 1.1. The answer is no. This implementation is ADaM compliant. Rule 6 implies that new record should be created when there is more than one baseline for the same record. In the previous example, the record at visit 5 has two different baselines and change, but no other records have multiple baselines. So only a duplicate record of visit 5 is created. In general, if a subject has different baseline for different records, there is no need to create any extra records. New records needs to be created only when there are two or more baseline values for the same record. Now let's discuss the third case, which is the time-matched baselines. In some analysis, especially in phase 1 studies, Some parameters are measured in a series of time points at each of scheduled visits. In those studies, the baseline could be defined as the values at each time point at the baseline visit. So there is a baseline per subject, per parameter, per time point. Right now, I'm showing you the SDTM data of such case. Here, please note that the baseline as well as the visit 3 visit records are having different time points captured as XOTPT. And from the time points, you can see that we have a 8 a.m., 10 a.m., 12 p.m., 2 p.m., and 4 p.m. records for both baseline as well as visit 3. In this case, there will be a baseline for each of the following time point, that is the 8 a.m., 10 a.m., 12 p.m., 2 p.m., and 4 p.m. But there will be only one baseline for each record. The value at 8 a.m. at visit equals to baseline will be and will only be used as the baseline for all 8 a.m. records. Similarly, 10 a.m. value at visit equals to baseline will be and will only be used as the baseline for 10 a.m. records. No need to create a new records in this scenario. Consider all these as one Considering all this, one can implement the ADaM dataset as shown in table 7 here. In this example, there are 5 different baselines per subject per parameter, and no extra records have been created. Right now, the ADaM dataset which I am showing you is sorted based on the time point variables, because of which after the baseline record for each time point you have the post baseline record for their respective time points. So here for time point 8 a.m. the first record is the baseline record, and then we have the visit 3 which is the post baseline record for that particular time point. And you can see that you have the base value populated from the baseline records, and the ABLFL is also populated as Y, and the change is coming from only the visit 3, which is the post baseline records for each baseline records for each time point. Now comes the case 4, which is the by visit baseline. For many trials, it is often that the difference of pre-dose and post-dose measurement, such as the interocular pressure, needs to be analyzed. In these cases, we can define the pre-dose measurement at each visit as the baseline for the record measured at each visit. If we are only interested in the difference between the pre and post-dose values, the ADaM implementation as shown in this table is sufficient. Here you can note that we have created a baseline record for each A visit values, and we have defined a post baseline record as well for the respective visits. And to distinguish between the baseline and the post baseline records for each visit, we have the base type value populated. In this table, the base type is needed since more than one record within one parameter is flagged as baseline record. So according to the ADaM IEG version 1.0 or 1.1, if there are multiple baseline records flagged for a given parameter within a subject, then base type values should be populated and contain the different values for the baseline records within a subject. So here you can see that to identify that which record is the baseline record, we have the base type populated accordingly. So for visit 2, if we want to know that this is the baseline records, along with the ABLFL flag values equals to Y, if we consider the base type, we will get to know that this particular record is the baseline record for which visit. And similarly, considering the time points, that is the post baseline, post dose, and the base type, you will get to have the records of all the post baseline records for the said visit uh, here. So in this example, we have one baseline and one post baseline records for each visit defined. The same can be identified from the base type ABLFL and TPT combination in this scenario. That's all for today. Thanks for watching. Let me know in comments if you want me to cover any specific topic.